Right, thank you for joining me. There's a chance of a pretty good storm Saturday into Sunday in New York. Thing is, I'm just not sure how big the storm is going to be, but rumor has it that it could be a pretty big storm. I mean, look at this, guys. I mean, look at this. 974 millibars right off of New Jersey. And the European model, oh man, it's really wild. Like, it's wild. It's showing 998 here. But in Atlanta, Canada, let's go North Atlantic right now, guys. Atlanta, Canada, 954 millibars. I mean, check that out, guys. I mean, look at that. But and then look at the European ensembles. Well, they're having this. Look where they're having the storm. Just check this out, guys. Very close call. Like really, really close. This is a close call. Like, and this storm isn't gonna be as fast as that bomb cyclone that just zipped up the coast. It was like really fast. This one is gonna be slower too. This is gonna destroy the sea ice, guys. Yeah, this definitely looks impressive, guys. I mean, the GFS though, not so much. Like I've been looking at the GFS. Righty. Now we're going to switch over to the GFS. So there's that coastal storm coming off the coast now. So let's look at this now. Righty, let's see. Yeah, I play games. I play Mortal Kombat, so just wanted to see how to do some moves. Righty. Yeah, the new Mortal Kombat X11 that just came out. All right. They got rid of a few characters. They got rid of Melina. Which sucks, but there we go. Here's the GFS. That's definitely a little impressive now. This is a little bit more impressive based on how far north the precip goes. So this is the northern extent of the precip for the 18Z run. And for the 0Z, it's just a little further north. So this is the main shield. It's in southern Texas. 18Z has it about the same area, so. And I want to have a moment of silence, 1 minute moment of silence for Kobe Bryant. Thank you. You know, he and his daughter were both too young to die. You know, it was just really sad. It's just really devastating when you lose people so young. You know, like his daughter Gigi. You know, she was only 13, and that's a really really terrible loss. Not just for the basketball community, but for Kobe's family. You know, his wife is now reeling. You know, is now reeling with his death and his loss. It's just so devastating. Now let's go back on the weather. I'm trying to maximize this for just a little bit. So this is where you want to look at the position of the low, right about here. So it's here. It was. This is what 12Z looked like, and now it looks like mostly in the same position, but you also want to see how deep does this upper level low get. In order for the storm to go up the coast, it's how quickly this tries to force it up. Looks like it's coming in a little faster. So you see this right here. If this is going to have a further south extent, like say up to like, say instead of like this, it's going to be more like this. This storm might end up going further west. Alrighty, so this is what you want to see now. You see this, how it looks pretty wavy. So see right here, the position where it is here. Where it is here, yeah, it does not look as impressive as the earlier run. So based on this, let's go to upper dynamics and go to 500 millibar height anomaly for right now. Hour 96. Yeah. So it looks a little. So this looks a little more impressive, guys. So. It all depends on how fast it swings down. Whether this is going to be a big event or not much at all. Let's go to upper dynamics, 500 millibar height anomaly. We have this. See how it's southwest, and then it's kind of like this looks a little sharper, just a little sharper. See how it's going west southwest, and then yeah. Okay, with the 564's line here. So it's a little more like, how to say this, sharper. And here, let's see here. Yeah, it definitely looks sharper. There's definitely a sharper inclination here. So now you're getting a combination here. So yeah, it definitely looks more impressive, guys. Oh wow, guys, look at that. Oh god, yeah, this could be quite a storm, guys. Yeah. And look at that. It looks like the storm might actually affect our area based on what I'm seeing here. You know, let's go to lower MSLP anomaly. Alrighty. So very weak storm though, very weak. So even though it looks more like it's going to be oriented in our direction, 2011, yeah, it looks a little stronger, guys. It definitely looks a little stronger. So 2005, oh wow. Yeah, this is gonna bomb out. This is definitely gonna bomb out, guys. Storm is heading our way, guys. So let's see. Position of the low, 1,000. So it is a little weaker. It's weaker and it's further north. So based on that, I'm going to say it's probably going to be mostly rain for New York City. Maybe a little snow, but let's look at precipitation type here. See, rain, 1001, not 1005. Where's that 1004? Let me go to lower dynamics. And this will be anomaly. That's what I want to see. Damn it. Regions, I'm going to do Mid-Atlantic or Eastern US. 1003, okay. 1003. So about the same location. Okay. So about the same location, a little weaker. I mean, a little stronger, just a tad stronger. But, let's see. But it looks like we are going to have a storm because the Euro is showing a 950 something storm. And the Navigem is showing a 970 millibar storm right here. Blizzard conditions for New York City. This could be the big storm of the year, guys. This could be the big one. Chicago, not too bad, guys. But I'm going to go to my YouTube channel. Hold on. I'm going to... Because right now, I'm going to advertise my channel, on my group. Well, I'm going to change the video now. This could be... Okay, guys. Storm forecast. Just, guys, see, I'm changing... now has major damn it now has major storm for NYC Metro as well as Southern New England. 1, 2, 3, 4, 5, 6, 7, 8. England, perfect. Has a major storm. Perfect save. I'm just gonna put that on my Facebook. Southern New England. 1, 2, 3, 4, 5, 6, 7, 8. England, perfect. Has a major storm. Perfect save. I'm just gonna put that on my Facebook. Southern New England. 1, 2, 3, 4, 5, 6, 7, 8. England, perfect. Has a major storm. Perfect save. I'm just gonna put that on my Facebook. Southern New England. 1, 2, 3, 4, 5, 6, 7, 8. England, perfect. Has a major storm. Perfect save. I'm just gonna put that on my Facebook. Southern New England. All right, let's go back. Here's what the euro was showing earlier today. So yeah, the euro was going bonkers, like, completely freaking bonkers. Yeah, the euro was just insane. Like, not with the location of the storm, but the strength, guys. Let's see now. You see how the precipitation is coming up. Let's go to MSLP anomaly right now. See how quickly it just went up to 1,003? So you're going to have the storm go into New England. Like, it's going to bomb out, because you see this right here. You see, this storm is going to transition its energy here. So you're going to have major phasing. You're going to have major explosive development. First of all, the water temperatures off of southern New England, off of the Carolinas, are extremely warm. Just look at that. It's going to be 995, I guarantee you, or lower. 992. You see that? Right there. 992, just like that. 983. Holy crap. And this is right in my area, too. Jeez, this is going to be one heck of a storm, guys. I mean, this is going to be... That's going to be at least maybe 6 to 12 inches of snow. I mean, 971, I mean, with that kind of development, this is going to be extremely heavy snow. One thing the GFS is not doing correctly is it's not anticipating heavy snow. It's really underestimating how much moisture there's going to be. First of all, with this kind of explosive development, you're going to have a lot of, and I mean a lot of, convection. You're going to have a lot of thunder snow being, not thunder snow, but, you know, convective banding features being thrown from the center of the storm to the northwest. You're going to have a lot of instability. You're going to have a lot of uplift. You're going to have a lot of, you know, evaporation going on. You know, pressures drop. You get more precip. So this right here doesn't make any. Well, this makes some sense, but guys, with this kind of explosive development, you're going to have a lot of precipitation. I mean, look at precipitation type right now. Let's look at a thermodynamics right now. 850 millibar temperatures. Not good. You're going to have a lot of dynamic cooling right in here. That's another thing that GFS screws up on all the time. It does not do dynamic cooling very well. And look at precipitation type. You're in the 850 line. Like you're supposed to have snow, and yet you're in the rain. And you're going to have north winds. Like New England from this is going to get like a foot of snow. I mean, this is all going to be snow here. This is going to be all snow. And let's look at how much snow is going to come down based on the GFS. Based on this, I'm going to say a general 6 to 12 inches here, maybe up a little more, definitely more than a foot, maybe 12 to 18 inches. So yeah, we're going to have a big storm, guys. We are going to have a major storm now. Illinois, Chicago area, not much. I mean, let me focus now. I'm back on Chicago. I mean, you asked me about Chicago, so let's see. Maybe a few flurry snow showers Friday night, Friday afternoon. That's about it. And maybe another burst of snow Saturday afternoon. That's about Saturday midday. So this would be a midday Saturday in Chicago. Not much. So yeah, maybe an inch or two total snow. 1 to 2 inches Chicago, like really not much. So between 1 and maybe 2 inches in the Chicago area. So yeah, Chicago, you're not going to get much snow. I mean, this right here, guys, I mean, this monster storm, this storm is having Gulf moisture. I mean, look at this. Gulf moisture, a rapidly intensifying storm. You're having all the ingredients coming together for a major, major storm, guys. So I'm going to be up until 2 a.m. doing this live stream because I need to see what the Euro is going to say. But all bets are it's going to trend further west because the operational has been trending further east but stronger, but the ensembles were the ensemble of the Euro has been trending further west. So we might have a monster storm in our hands. I mean, look what the NavGem is forecasting. Look at that, guys. 974. Boom. This makes more sense. Probably gonna have a lot more precip here too. You're probably gonna have very heavy snows. I mean, this is gonna be a lot of snow. First of all, it's gonna start at hour 120. And this storm isn't even moving that fast. This is in 6-hour increments. This storm is gonna last a while. The bomb cyclone, the one that happened in 2018, the winter of 2017, 2018, the January bomb cyclone, was zipping so fast. It was like here, and 8 hours later, it was like in New England. This one is going to have a lot slower motion because this storm, I mean, look at this. It's hardly moving. I mean, it's moving fast, but New York City is going to get a good, let's say, it's going to start about hour 114. I'm going to say 115. So 20 hours will be about hour 132, 18 hours. So a good, I would say, 18 to 24-hour storm. So this could produce anywhere between 12 and maybe 24 inches of snow. I mean, this is based on what I'm seeing right now. Anything could change. I mean, it could very well do something like this and impact Atlantic Canada and give very little to the East Coast. I mean, the models are still trending all over the place. Look what the Canadian is showing. Yeah. Oh, this is the new model of the Canadian. I mean, look what the midday run was saying, the 12Z. And also, just want to notify you all, I'm now taking classes at Stony Brook. My major, atmospheric science. Finally, I am majoring in what I am doing online. And yes, my planned major is not atmospheric science, it's actually broadcast meteorology. I'm planning to major in meteorology with a concentration in broadcasting because this is something I'm very good at. I've been doing this for 10 years. Mostly on the radio. In fact, Wednesdays I do the weather for David Wolfson, WATD. I can't do it every single Wednesday because of class. But I did last Wednesday and I'm going to do this Wednesday too. Let's see. So they're showing a storm. There's going to be a storm. Like all the models are showing a bomb. I mean, let's go to the North Atlantic Oscillation right now. The reason this is happening is because the NAO is going negative. Briefly, though, but it's going negative. Oh, I like what I see here. I may just try neutral after this. Yeah, that's actually a very good sign. If you want snow, you want the NAO to be at least neutral to negative. Neutral to negative, and PNA, you want the PNA to be positive, neutral to positive, So good sign, it's positive now, and you want the AO to be negative as well. Or neutral to negative, preferably negative. I mean, that one is, but most likely it's probably going to be positive. This is happening because the Arctic oscillation, well, the polar vortex is very strong. This depicts a very strong polar vortex. This depicts a polar vortex being weak. You know, when we have all these Arctic outbreaks, polar air masses coming to the United States, they're like, oh, the polar vortex is coming down. Like what happened in 2013, 2014, 2012, 2013, 2014, 2015. All those instances, the AO was very negative. You had AO values like down here even. What happened was the polar vortex got disturbed by something called a sudden stratospheric warming event. Basically what happened was there was a bubble of warm air that formed over the polar vortex, which disrupted its low pressure cycle. And pieces of the polar vortex, sometimes the main part of the polar vortex would come into the United States. Usually what would affect Siberia would affect us. But because of climate change, the thing that would usually predict the outcome of the polar vortex really hasn't really been working much. Like, we haven't really had any true Arctic outbreaks this winter. I mean, we've had some pretty strong intrusions, don't get me wrong, but really, the last time we had a good Arctic outbreak was right about here. So we are about we might not see another Arctic outbreak this winter. If this trend continues, we might not see another good Arctic outbreak. Plus the PNA, I mean, the NAO is trending neutral, but the PNA really not a part of a big Arctic outbreak. The Antarctic oscillation. Really, if you want strong Arctic sea ice in Antarctica, you want this to be positive during the during their summer, you want this to be positive. You want a positive AAO or neutral to positive AAO, Antarctic Oscillation. Like you want a stable positive, like what happened during the 2014-2015 winter, 2012-2013 winter, when you had record sea ice in Antarctica. The values were positive and they were staying in positive values during their winter. So when it's July, August, when it's June, July, August, September, you want stable positive values. But let's go back on talking about the storm now. See if anyone's talking. So let's go back and look at the Canadian now. The current run of the Canadian. So now we're up to hour 48. Well, for now we could look at the volcanic activity, but the Tau volcano is mostly done. Like it's no longer an eruption. They lowered it to a 3. They're probably going to lower it to a 2. And also the volcanic quakes are down to 175 per day. So that's good news. There's still quakes that's happening in the area, but let's see here. Okay, that's not Batangas. Let's see. That's definitely near the caldera, but it's pretty deep. It's 34 kilometers deep. That's probably the secondary magma chamber. That's where the secondary magma chamber is located. This is, I would say, just based on what I'm seeing here, that's going to be west of Lake Tau. It's going to be over, okay, so this is Lake Tau right here. This is the caldera. It's going to be west of the main portion of Lake Tau. So if I'm going to estimate where it's going to be, I believe this would put the quake somewhere around this area here. Just west of Agoncillo, and between San Nicolas and Agoncillo, maybe in this area, around the Lemery area, I believe that's where the quake happened. Yeah, see, pretty far west. It's another crater. Okay, let's go back now to the CMC now. So let's look at space weather. I mean, we haven't had sunspots in a very, wow, darn it. So, you know what? Even though I'm not a fan of SUVs, I'm very much interested by the 2001 Chevy Suburban. The main reason why is their 3-liter Duramax diesel. Their, yeah. A 3.0 V6 diesel. Now it's going to get up to 30 mpgs. That's my estimate, 30 miles per gallon. Because here's the thing. It gets 33 mpg on the highway. I mean, come on. If that gets 33 mpg on the highway, I'm going to say with the Suburban, it's probably going to get 29, 30 miles per gallon. Yeah, 33 mpgs on the highway with the Chevy Silverado. I mean, if you're a frugal driver, you're not going to be heavy lead-footed. You're going to use cruise control, low like speeds between 60 and 70 on the highway. In the Chevy Suburban, you could even get between 32 and 34 mpgs, especially with cylinder deactivation. It's also going to be offered on the Suburban Duramax. You could have cylinder deactivation. You could definitely get low 30s mpgs. And the thing is, diesel is cleaner burning. Like it produces less carbon emissions than gasoline does. Produces more energy, more efficient. I don't know why gasoline is taxed lower than diesel. I mean, trucks I understand. I think trucks and cars should be given a different price. Like cars should be charged, should be taxed at the rate that gasoline is taxed. If you tax gasoline at the same, if you tax diesel at the same rate you tax gas, diesel would be 10 to 15 cents cheaper than gasoline, even if you taxed it the same rate. Why? Because diesel is unrefined. Yet, while diesel is unrefined, it's actually has more energy, has less tailpipe CO2 emissions, but more soot and more sulfur. But now with cleaner diesel engines, you could actually eliminate that with filters. So it's like, and you could actually have diesel itself that's actually cleaner, chemically cleaner. So I think they should do what England did and try to incentivize more diesel cars, especially hybrids. So I think once diesel prices are lowered, states with the lowest diesel tax, states with lowest diesel price, diesel tax. So let's see for diesel. Hmm. No. No, 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 no. Okay, you have a 46-cent diesel tax in Connecticut. Wow. New York. Huh. That's funny. New York City has less taxes on diesel. But it's probably because of the federal government. Hmm. What is a diesel tax? 18.4. Hold on. I'm about to go back to the models. Okay, let's see. Oh wow, 50, who has a plus 50? Illinois. Huh, wow. Let's go to Vermont, which is a Bernie Sanders state. Vermont. 32 cents, not bad. That's not very high at all. That's less than Massachusetts and less than, well, about Massachusetts level. They're not even mentioning the diesel tax. I mean, they're mentioning a state diesel tax. Oh, wow. Excludes diesel tax of 24 cents? Why are they charging 6 cents more per diesel than gasoline? Makes no sense. Alaska diesel. Just gonna. Alrighty. Well, it's 5 cents cheap, more expensive because of the federal tax. Alrighty, let's go back now to the Canadian. And let's go to. All right. So guys, I'm live again. Currently looking at the nav gem again. Sorry, my stream went down for a bit. Okay, stream is back, guys. Stream is back. Just want to let you all know that the stream is back. Okay, now that the stream is back, let's look at the CMC. Let's look at the Canadian guys. For dynamics, let's look at 500 millibar height anomaly, and we also could look at some vorticity maybe. Yeah, guys, we're definitely gonna have a storm. Let's look at vorticity. Come on. Yeah, this is what you want to look at. Are we gonna have a major storm? Let's compare this to the nav gem. Come on, just load. Yeah. 500 millibar height anomaly. So you see how deep this is right here? Okay, you see this right here. All right. So let's compare this to the Canadian. So we're definitely going to be having a storm go up. That's weird, huh? Looks like the Canadian wants to, again, shunt it off the coast. Alrighty. What's surprising me so much, it's even though you're having a southwest flow loft, keep in mind, I mean, if this is gonna be a little deeper, like this maybe, instead of being like this, if it's going to be like this or even like this, you're going to have a major storm. Right now I'm going to go to the GFS now. I mean, the GFS definitely has a major storm. Either way you look at it, the GFS, guys, is now forecasting a major storm for the New York City area. I mean, it went from being further east to being further west. The NavGem, the GFS, the two major models are further west now, guys. I mean, look at this. Let's go to 850 millibar temps. This is what I find hard to believe. Okay, so right now we're in trenches on pretty cold air aloft, even though it's not, it's in the 40s at the surface. So about hour 100 is when we're going to start seeing the storm approaching. As you can see, we stay in the freezing level. Yeah. You're going to have a lot of evaporational dynamic cooling, so this doesn't make any sense, guys. 925. Dynamic cooling goes from the upper levels down to the lower level, so especially when you have warm tongues. So it might stay all snow. I mean, look at that. This may say precipitation type is what you want to look at. And the GFS doesn't really do too well with temperatures. For that, you got to leave it up to like the high resolution models, like the Euro, the NAM, the NAM 3KM, and the Canadian RDPS. See, New York City stays on the edge. So you see how we're on the edge of this snow? But as a major storm for Boston, though. Yeah, doesn't make any sense, guys. I mean, 998, 1, 2, 3, 4, 5, 6. 986 millibars. And let's see snow, how much snow is going to come down based on what the GFS is forecasting. This is based on the GFS, guys. Ready, so yeah, you see what the GFS is doing. You're gonna just basically move all this heavy snow and just put it down here. Like, this is not gonna happen. I mean, yes, you're gonna get a lot of snow here too, probably more than what is forecasted here. You see how it goes? It goes. You see how it zips up and then goes down? No. You're gonna have heavy snow in the New York City area. Let's go to the GEFS, the ensembles. Yeah, it's probably gonna show a lot of snow too. Let's watch a little documentary on Krakatoa while the rest of the model is loading. Part of this is going to be from a documentary called Krakatoa.
Indonesia is a group of thousands of islands in Southeast Asia. Two of the largest islands in this archipelago are Java and Sumatra. Separating them is a busy waterway known as the Sunda Strait. Today, only a remnant can be seen of the 1883 volcano. Volcanologists have pieced together Krakatoa's eruptive history.
Yeah, it's called it's probably called that ancient that. Let's see if I.
Islands in this archipelago are Java and Sumatra. Separating them is a busy waterway known as the Sunda Strait.
Yeah, it's called Rakata, the remnant island.
Today, only a remnant can be seen of the 80. Volcanologists have pieced together Krakatoa's eruptive history. Separating them is a busy waterway known as the Sunda Strait. Today, only a remnant can be seen of the 1883 volcano. Volcanologists have pieced together Krakatoa's eruptive history. In 416 AD, an ancient Krakatoa destroyed itself in a massive explosion. Over the next 1200 years, regular minor eruptions rebuilt the volcano. These small eruptions helped release the pressure created by the enormous geological forces beneath the island. But over time, a plug of thick, viscous magma formed in Krakatoa's throat, preventing the gases and magma from escaping to the surface. The eruption ceased, and by 1883, Krakatoa was a time bomb, waiting to explode. Just before midnight on the 9th of May, 1883, intense pressure building deep beneath the Earth's crust broke through the line of weakness directly below Krakatoa. Magma, moving towards the surface, split the crust apart, creating a large tremor. After the tremor at the lighthouse, in the early morning of the 20th of May, the tranquil island of Krakatoa burst into life. Intense pressure building beneath the most northern crater was finally released.
Soon, only a small part of blue sky was seen on the horizon.
This initial eruption, however, was only the prelude to a far greater explosion yet.
This is so funny. No, of course it's that one. Yeah, I just had a quiz on super stalls. Got 100%. Yay. Just know a lot about MD80s. You know, also I watched a video about super stalling, so. And then I took a quiz after watching the video, of course. Quizzes are fun. Especially when you know you're going to get 100. Anyway, let's see now. Alrighty, let's go back to the GFS. Oh crap, guys. It looks like this one actually may send up further to the south. That's what the ensembles are saying, guys. Yeah, I don't like what the ensembles are showing right now. Yeah, I mean the operational looks really fun, but yeah, the ensembles are not showing anything good. I do not like what the ensembles are showing right now, guys. Yeah. Needless to say, the ensembles suck. Ensembles usually are herald to what is going to happen. Yeah, guys, the ensembles are horrible. Oh, God. Oh, look. A Shinneck. Look at that. Wow, that's a really strong Shinneck. That's a Shinneck wind event. Basically, a warm air because of downsloping. See, it's cold air coming into the mountains, but because of the Chinook effect, you know, the downwind effect, you know, you're going to get some warm air. So it's the downslope effect, which is actually going to create its own warm air. Even though you're having a northwest flow, guys, look at that, northwest flow. A lot of warm air here. Also, you're going to be in a ridge, so yeah, there's that too. And let's look at the 12Z, guys. Let's just say the 18Z was perfect. Yeah, I love the 18Z, guys. I mean, the 18Z was just amazing. But the Midnight Z run, yeah, further east. But the operational, further west. Yeah, makes no sense, right? Yeah, it's probably going to correct itself by the 6Z run. It looks like this ain't going to happen, guys. I'm sorry to say this, but nope. And now I have to wait for the euro to load, so. Let's look at some earthquakes now. Latest earthquakes. Alrighty, look at that swarm there. That's one of those deep period event, very deep earthquakes. Yeah, I don't know if that's related to the volcano because there's no moment temperature. It's very far from the volcano. But it could be related, but probably not. It's probably not related to hotspot. Hotspot volcanism, I mean, let me see if that's related to Mauna Kea. I mean, that's pretty deep. It could be related to its magma chamber, possibly. Let's put in its coordinates and see if that's Mauna Loa. Mauna Kea, I meant. Yeah. Future activity. It could be a little explosive. The last eruption of Mauna Kea was 4,600 years ago. Because of this inactivity, Mauna Kea is assigned a USGS hazard rating of 7 for its summit and 8 for its lower flanks, out of the lowest possible hazard rating of 9, which is given to the extinct volcano Kohala. Since 8,000 BC, lava flows have covered 20% of the volcano's summit and virtually none of its flanks. Despite its dormancy, Mauna Kea is expected to erupt again, although there will be enough warning to evacuate. The telescopes of Mauna Kea would be the first to detect a minute amount of deformation resulting from the volcano swelling, acting like expensive tilt meters. Based on early eruptions, such an event could happen anywhere in the volcano's upper flanks and would produce long lava flows, mostly lava, of 15 to 25 kilometers. Long periods of activity could build a cinder cone at the source, although not likely in the next few centuries. Such an eruption will probably produce little loss of life, but significant damage to infrastructure. Geology. The shield stage lavas that build enormous main mass of the volcano are tholeiitic basalt, like those of Mauna Loa, although created through the Mexican primary magma and subducted oceanic crust. They are covered by the oldest exposed rock strata on Mauna Kea. Okay. Thicker flows. In addition, explosive eruptions and built cinder cones near the summit. These cones are considered the most recent eruptive centers of Mauna Kea. Its present summit is dominated by lava domes and cinder cones up to 1.5 kilometer diameter and hundreds of meters tall. Mauna Kea is the only volcano with distinct evidence of glaciation. Similar deposits probably exist in Mauna Loa, but have been covered up by later lava flows. Okay, let's see. The most recent cones were built between 9,000 and 4,500 years ago atop the glacial deposits. Although one study indicates that the last eruption may have been around 3,600 years ago. Hold on. Yeah. So let's see where we are. At their maximum extent, the glaciers extended from the summit to between 3,200 to 3,800, 10,500 and 12,500 feet of elevation, meters of elevation. A small body of permafrost, less than 25 meters, 80 feet across, was found at the summit of Mauna Kea before 1974 and may still be present. Small gullies edge the summit, formed by rain and snow-fed streams that flow during winter melt and rain showers. On the windward side of the volcano, stream erosion driven by trade winds has accelerated erosion in a similar manner to that on older Kohala. Mauna Kea is home to Lake Waiau, Lake Waiau, the highest lake in the Pacific Basin, at an altitude of 3,969 meters, 13,022 feet. It lies within the Pu'uwaiu cinder cone and is the only alpine lake in Hawaii. The lake is very small and shallow, surface area of 0.73 hectares or 1.80 acres, and a depth of 3 meters or 10 feet. Radiocarbon dating of samples at the base of the lake indicates it was clear of ice 12,600 years ago. Hawaiian lava types are typically permeable, preventing lake formation due to infiltration. Either self-bearing streams alter the volcanic ash to low permeability clays, or explosive interactions between rising magma and groundwater, or surface water during phreatic eruptions formed especially fine ash that reduce the permeability of the lake bed. Wow. Anyway, let's go back to the European. So there's a chance we may not get a storm at all. Yeah, there's a chance nothing may happen at all. I mean, even though the GFS looks promising and really, really like wow, the GFS is the Canadian nav's been so promising. Just keep in mind this is an 18Z run, and anything can change. I mean, look at this right now. We're gonna have to wait for midnight run to come in, but I'll probably be asleep by that time. Let's see if he's live right now. I think he's gone already. He's still live. Wow. What? Wait, did I meet this? Oh crap, I did.
Get ready to stitch him up.
Our path is made today.
Let me meet the cipher now. All right, yeah. Let's go here. I mean, this is crazy, like really crazy, guys. Wow, New York State is the number one, two, three, four, five, six, seven, eight. Number 8 for the least CO2 per state. Well, of course, Wyoming, Kentucky, West Virginia, Indiana are the most carbon intensive states, producing 2 pounds of CO2 per mile. Mm. The average passenger car emits about 411 grams of CO2 per mile. Let's see what the Tesla calculator is showing. Every kilowatt hour. No. Let's see. I'm gonna see if gas cars. 3 miles. So, okay, let's say 3 miles per kilowatt hour. So the most polluted state will be 2.8 pounds grams per pound. And let's see. And let's see. It's 2 point how much? 2.08. Okay. 2.08. So 943 grams. Let's see, 3.11 miles. Okay, let's see. That is going to be 303 grams per mile of CO2 emitted. Grams in pounds of CO2 per mile. Of course, 2.02, actually 2. It's 0.08. Yeah, 2.08, yeah. 2.08 divided by 3.11. That's about 0.66. So still less than the average gasoline powered car. That's good. $650 miles. And let's use the most gas. Wait a second. Kilowatt hour. If I'm getting, okay, if I'm getting, let's say, watt hour, which means, okay, kilowatt. If I get 3 miles per 1 kilowatt hour, that'd be 1,000 watts. Say I'm getting 3 miles per kilowatt hour. That's about 333. Wow. Imagine New York State, 100 miles per gallon. Let's see. Wow. Gas efficiency. Okay, let's be more realistic. Let's put maybe 30 mpgs. 316 pounds less. Vermont. Wow, 2 pounds. Let's go 1,000 miles a gallon then. Huh. Your Tesla, for this trip, your Tesla put 10 pounds less CO2. Of course, let's go. 1, 2, 3, 4, 5, 6. Fine, let's be more realistic. Let's go 60 miles a gallon. Let's be more realistic here, guys. Okay, 2 pounds, 70 pounds less. Let's go 65,000 miles. Wow. Wow, 7,000. Let's go 100 miles per gallon. Woo! 12,000 pounds of CO2 less. Let's go to 25 mpg. Boom! 51,000 pounds less. Let's go to 100,000 pounds. Million. Zero pounds. Of course. 1, 2, 3, 4, 5, 6, 7. Let's take 20 zeros off. 6. Okay, let's take 6 zeros off. Now it's more realistic. Boom. Okay, let's go to 50 miles per gallon. Prius hybrid, right? 25,000. Let's go 650,000 miles, right? Boom, 257,000. Let's go 65 billion miles. Wow. Let's go to 3, Let's go to 0.1. Wow. Let's see, got a car, perpetual, hypothetical perpetual motion machine. Wow. Okay, fine. Let's go to 650. Wow. Okay, let's do. And let's go to 200, 300 watt hour per mile. Man, if this happens, oh my god. Like, I mean, even the GFS is like, yeah, but when I saw the ensembles, I'm really disappointed now, guys. I'm just like, even 1978, the T train looks really cool. Oh, look at that. It looks like it's raining, or is that ice? Hmm. I think that's freezing rain. I think there's snow on the ground here. Those are icicles. Yeah. Soon the train is even moving, so yeah, that could be icicles. Yeah, today's trains look far uglier even than the 70s. I think they should bring back those trains. I mean, look at this. You can even see the heat coming off of it. This is what weather's like in Mecca, Saudi Arabia.
عاصفة قوية جدا في الحرم المكي.
It happens in the summer because Mecca is right along the Red Sea and you get thunderstorms there.
ما تكاد ترى شيء. جابك الله. مطر. عاصفة قوية.
Just trying to pass time. Let's see. Let's go back to USGS. Perfect. Let's see. Small earthquake swarm in Long Valley. Nothing impressive. Biggest quake there is 1.4. Like, it's nothing. That's like. Let's go to 1990. A minimum 3.5, maximum, let's say 10, you know. Draw a rectangle on map. Let's go to Long Valley, because, you know. I want to do it only inside the caldera. Here it is. Actually, let's go to 4.0. I want 4.0 is stronger. That's a normal faulting right there. Let's see. Thrust fault, you'd have a white here and blue on the sides. Yeah, that's not a thrust. Normal fault. No, that's not normal faulting. That's oblique faulting right there. More oblique. Oh wow. That's oblique. That's more strike slip. More indicative of a strike slip faulting there. But that was not related to Long Valley. I'm gonna say that's not related to Long Valley. Why? Like this would be related to Long Valley. Yeah, that could be more. That could be. That's more thrust. That's more thrust fault. Let's do a new search now. So let's do 3.5. Same location. Search. Now, 2014. Moment tensor indicates that it could be a that's what I saw earlier. Instead of strike slip, it was oblique faulting. Normal. So that's more indicative of normal faulting, I believe. Thrust fault would be dark in the middle. Normal fault would be, yeah, white in the middle with dark on the sides. Blue with dark on the sides. Let's see what this is. Yep, that's normal. Normal to maybe strike slip. Come on. Normal, that's divergent, that's convergent, that's so reverse faulting meant that's coming together. That's a thrust fault, normal faulting. So this is indicative of divergent faulting right over here. That's divergent faulting. That's a bit of a, wow, that's divergent faulting. That's interesting. Driftway catalog, let's go back to 1980 and make it from 4.5 now. Search. Now we're raising the stakes. We're raising the so that's in the caldera. Now that's in the caldera, guys. Oh, great. No. So oblique faulting. Yeah, oblique faulting. Oblique. And yet oblique faulting. So this is definitely strike slip. So guess what? It was a oblique strike slip fault. An oblique strike slip right there. 6.2, 1980. Now let's see what this was now. Oblique strike slip, looks like. Oblique strike slip. Again, very far from the caldera. Oblique strike slip. So very similar faulting, yeah. Oblique strike slip. Or oblique faulting, so yeah. Rapid fire. The only person who mentions rapid fire is Ben Fariello. I bet he was the one who, well, maybe it was Ben Fariello who did this. Hey, Ben. Yeah, Ben Fariello probably is the one who mentioned that. Hey, you know what? Let's actually change the location then. Let's go. I'm gonna do within the Caldera boundary then. So 3.9, and this time we're gonna draw a rectangle on map. So we're removing that, and now we're going to Yellowstone now. This is going to be within the Caldera boundary, guys. A 4.8. Let's see what kind of quick that was. Looks like a strike slip to me. Definitely a strike slip. That is very scary. The fact that Yellowstone had a 4.8 in 2014.
By the 27th of May, 1883, the large eruptions on Krakatoa had abated. During this relative lull in activity, an eerie calm now shrouded the mountain. Along the coastlines of West Java and southern Sumatra, the morning of Sunday, the 26th of August, 1883, was as any other. At 6 minutes past 1 on the afternoon of Sunday, the 26th of August, 1883, all three craters on the volcanic island of Krakatoa erupted in a massive volley of explosions. The enormous pressure that had been building for hundreds of years was suddenly released. The ship closest to Krakatoa that afternoon, just 12 miles away, was the Governor General Loudon.
Keep her away from the coast! We mustn't be drawn inland.
Hot, sticky volcanic ash fell from the dark clouds, smothering the ship. At 5:30 the following morning, the first of 4 truly cataclysmic explosions occurred on Krakatoa. The volcano erupted, literally ripping itself apart in an explosion equivalent to the power of 1,000 atomic bombs. Molten rock lying inside Krakatoa's magma chamber for 200 years of dormancy was light in color and cool in temperature. After the initial eruption in May, the magma chamber was part emptied. That void was filled from below by dark-colored magma that was extremely hot in temperature. It was a lethal cocktail. As the two mixed together, the intense heat of the dark magma created huge amounts of gas that expanded, eventually creating enough pressure to cause the volcano to erupt with terrifying force. mixing of two magmas beneath Krakatoa was the direct cause of the massive explosions. But when combined with the volcano's unique position in the Sunda Strait, these explosions generated a series of giant tsunami. Some would be the largest waves ever witnessed.
It was landslides that generated such big tsunamis.
At 6:44 on the morning of the 27th of August 1883, the second massive eruption occurred on Krakatoa. Pyroclastic flows of dense material cascaded down the flanks of the volcano, and immense submarine slides generated giant shock waves in the surrounding ocean. In the Sunda Strait, the shock waves
It was not pyroclastic flows that caused the massive tsunamis. It was the landslides. Like what happened last year. Well, that generated the major tsunamis. Landslides, like what happened last year at Krakatoa. Well, not Krakatoa. Let's see, has it even? All right, I'm back. Anyway.
Molten rock lying inside Krakatoa's magma chamber for 200 years of dormancy was light in color and cool in temperature. After the initial eruption in May, the magma chamber was part emptied. That void was filled from below by dark-colored magma that was extremely hot in temperature. It was a lethal cocktail.
That's how
As the two mixed together,
Let's talk about this.
were witnessed as huge crests of water.
God. Counter into the wave now! As fast as you can! Back yourself down!
Of a tsunami. The Fourth Point tsunami stripped the sand from the beaches and destroyed everything in its path. It seemed like the end of the world, but worse was yet to come. At 10:02 on the morning of the 27th of August 1883, Krakatoa exploded once more, this time with such extreme intensity that it was heard over a 1/12 of the Earth's surface. The sound of the detonation was carried 2,000 miles south to Perth, Australia, and 3,000 miles west to Rodriguez Island in the Indian Ocean. It remains the longest distance traveled by any airborne sound in recorded history. When Willem Bering, the controller of Ketimbang, witnessed this huge eruption, he realized that the explosion would produce a tsunami of enormous size. The tsunami generated by Krakatoa would travel across the Sunda Strait at approximately 60 miles per hour, taking just 20 minutes to travel the 23 miles to Ketimbang. At 10:45 on the morning of the 27th of August, 1883, the fourth and final eruption tore Krakatoa apart. When the ash and smoke cleared, the shell of the volcano had collapsed beneath the surface of the water into the empty magma chamber.
So it didn't technically
All that was left was a remnant of the volcano, known as Rakata, and the existing islands of Valaten and Lang.
This volcano is from the 1883 eruption. This one is from the 1416 eruption. It was one big volcano. It was a stratovolcano that basically blew itself apart in a VI7 eruption, by the way, super eruption. No, I did not know that. Oh, wow, yeah. As a Sebastian Visaino. The Zumwalt. It's a Zumwalt class, I believe. Independence class, my bad. Let's see now. Oh, sorry. No, it wasn't original video. It was fake.
On August the 26th, 1883, the tiny volcanic island of Krakatoa erupted, creating one of the worst natural disasters in recorded history. In less than 48 hours, it destroyed hundreds of towns and villages and left more than 36,000 people dead. Those that survived the eruption left diaries, eyewitness accounts, and interviews. They were collected by the geologist Roger Verbeek, one of the few scientists to have witnessed the eruption. This film is based on those accounts. I lived. Tens of thousands didn't. Some of them were my friends. I've spent the last 2 years of my life trying to piece together the terrible events of August 1883. We were living in the most volcanic region on the planet, Indonesia. There are more than 100 active volcanoes here. Krakatoa is just one of them. The volcanic island of Krakatoa sits in the middle of the Sunda Straits, 30 miles from the mainland. For centuries, the people here have lived within sight of the volcano. We thought it posed no threat. I could have saved these people. They witnessed the last days when the world changed forever.
Contracts have been issued for the pepper and the customary 2.5%, which brings us higher yields than Mr. Debris had initially.
It's doing it again, Mama. The world's shivering.
How much money's left in the reserve account?
Nothing, Tuan. And we still owe.
Tips.
75 guilders interest on less
Easy.
than that.
Willem.
If we don't get the commission on those coolies...
Righty, I'm just gonna pause it for a minute. Alrighty, let's go to European. Mythalpy anomaly. Oops, no. 500 millibar height anomaly. That's what you want to look at, guys.
Forces are out of control.
I'll see to it. It's fine, I'll see to it.
Willem, have you thought about it?
Thought about what?
Please.
Joanna, I'm sorry, but I can't leave Cat and Bang. The harvest to arrange, the market opening on Sunday, it's impossible. You know, maybe in a couple of weeks when things...
What about the tremors? They're getting worse.
In your imagination. It's been rumbling away for months. Please, Joanna, you're going to worry yourself sick about this.
I'm sorry, I can't help it.
Anyway, go where?
Anywhere. Batavia, the hill farmer? I don't know, I'm sorry.
See to the horses.
The bearings. Willem was controller of Kattenbang, a Dutch outpost. He struggled on his meagre government salary. His wife Johanna was 26 years old and a mother of 3. We met several times that summer and never saw eye to eye. I should have listened to her. In May 1883, I visited the Shirt family. Having heard reports of increased volcanic activity, I wanted to see this for myself. The Shirts, a Dutch family, lived and worked on the 4th Point Lighthouse, 30 miles to the east of the island of Krakatoa.
Of course it's dangerous if you're sitting on top of it, but we're perfectly safe here. There's 30 miles of sea between us. It's the best seats in the house. Enjoy the show.
This is the island of Krakatoa, with its 3 peaks.
And where did you land?
About here.
Weren't you scared?
Scared? No. I was too busy collecting samples and getting scratched to shreds in the jungle.
What makes it explode? Erupt, I mean.
Do you still have that piece of pumice you showed me?
Yes.
We have to live here.
Oh, it's just Roger. Please.
No, it's not him, it's just...
The answer to your question lies in the bubbles. You see them?
I'm worried.
It's like this beer here. It's full of bubbles. You shake the beer, the pressure builds up inside. The bubbles need to escape, but they can't until... Oh!
Joseph, it's past your bedtime. Say goodnight to Mr. Verbeek.
Good night, Joseph. I've enjoyed our conversation very much.
You can keep it.
Thank you. 2 scientists sharing their knowledge.
Come on, Yusuf.
Wait. Where did you say you found this?
Found it on the beach. Why?
The pumice Joseph gave me held the secret of Krakatoa, a sign of what was happening deep inside the volcano. But at that time, I had no idea what it meant. On the 20th...
Okay, I'm going to pause again and look at the European. Let's see, I think hour 72, yeah. Can you update? Alrighty. Yeah, we're not going to get a big storm, guys. Why I'm thinking we're not going to get a big storm? Because the piece of energy that's supposed to produce this big storm is here, and what? Excuse me, sorry. We have 998 millibar low here, 945 here, which means something's going to happen between here and here. Something is going to happen, guys. I mean, the dynamics looks like a 500 millibar height anomaly again. Let's go back to the live stream. Alrighty. Alrighty. Sorry.
20th of May, Krakatoa began for the first time to emit vast quantities of smoke.
So I'm just waiting for the next run of the Euro to load. So for now, I'm going to be watching this video.
On the 20th of May, Krakatoa...
Yeah, I'm watching a documentary in Krakatoa. Because, you know, volcanoes affect the weather, so this is all related.
On the 20th of May, Krakatoa began for the first time to emit vast quantities of smoke. It should have been a warning to us. On the 20th of May, Krakatoa began for the first time to emit vast quantities of smoke. Krakatoa began for On the 20th of May, Krakatoa began for the first time to emit vast quantities of smoke. It should have been a warning to us. Vast quantities of smoke. It should have been a warning to us. But for some, this was just a chance to make money.
Captain? Captain!
You salute your commanding officer.
J.H. Lindemann, captain of the Governor-General Loudon. Since the death of his wife and only child 2 years earlier, he'd been reduced to ferrying passengers around the local area.
Listen to this.
J.H. Lindemann, captain of the Governor-General Loudon. Since the death of his wife and only child 2 years earlier, he'd been reduced to ferrying passengers around the local area.
Listen to this.
Join the excursion of a lifetime. Take a boat trip to the furnace of the gods, Krakatoa, and walk on a live volcano, one of the greatest natural wonders of the world. My hotel guest, your ship.
The Loudon is not a pleasure steamer. Furnace of the gods is built.
Come on, Lindemann. We'll make a killing be like the old days. Well, then it seems I wasted my time. Enjoy the cigar.
Carrot. Morning tide's at 6 a.m. Tell your guests to be on time.
Apa tu kamu berdua, ha? Sayang. Adakah harus aku memanggil kamu tuan? Mari kita kelihatan.
Okay, let's see the euro now. It looks like, let's go to regions. Actually, no. Let's go back to MSOP. Height anomaly. Looks like we're still stuck. Okay, depends on. Okay, what's the part that's gonna produce? It looks like it's this part right here. You see this here? And let's look at the GFS here now. This is where the European is right now. And based on what the European is showing, it's very similar. No, sorry. Let's look at the GFS and Euro. Compare those two runs. GFS and the Euro look very, very similar. I mean, the only difference between these two runs, can't even spot the difference, honestly, in Euro. Now there's a difference here. Okay, now let's go to the midnight run, okay? GFS and Euro, okay. Okay, 72, European, okay. Wow, that looks really, really impressive. Damn it. Yeah, looks like we're not going to get a big storm. I mean, the European is all over the place now. Say for maybe 30 more minutes. You know what? I'm going to pause the video for now. Alright, thank you all for watching, and bye. Well, thank you all for watching, and have a great day. Bye. And in the stream right now, guys.